For function basics, so the first one says a blank is a set of ordered pairs, and that is going to be a relation. So a relation is a set of ordered pairs. A function is a special relation between two variables such that to each value of the independent variable called the domain, and hopefully remember domain is x, there corresponds exactly one value of the dependent variable, commonly known as the range. So independent is our x, dependent is our y. All right, so from here, example 1 says, determine whether each relation represents a function, yes or no. Okay, so in order to represent a function, the x values cannot repeat. So for letter A, it's their ordered pair x, y, so here's x, 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 and x. So if we look at the x's, we see that the 2 repeats. And since there are 2 repeats, no, it is not a function. All right, for letter B, we do the same thing. It's a list of numbers, so an ordered pair. So we have x, 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 x. 1, 2, 3, 4. The x values do not repeat, so yes, this is a function. All right, for letter C, so when you look at these columns here, you're going to look at this column. This is the x column, and this is the y column. So we look at Andy, Ruth Ann, Liz, Ken, and Sean. No name repeated in the x column, so therefore, yes, it is a function. And for letter D, we look at the mapping here. So if you look at the x mapping on the left side, you'll notice that they only have one arrow coming out of each number. So -2 corresponds to -1. 1 corresponds to 4, 3 corresponds to -3, and 4 corresponds to 2. No x value corresponds to 2 numbers on the y side, so therefore, yes, this is a function. And again, you just look at this. So right here, right here, right here, and right here, there's no more than one line coming from each one, so yes, it is a function. All right, so for function notation, it says f of x, which we read as f of x, and you could use other letters as well. So f, g, and h are used to name functions, so you could say f of x, g of x, h of x, and so on. Y equals f of x, this is the value of f at that number x. And then last but not least, f of 2 equals 9. So hopefully recall that this is f of x, so it's written right above, and I'm going to write it here again. So this x, they're taking the same spot, so this is actually x, and this y is right here, so that's going to be y. So when you write an ordered pair, it makes sense that it's 2, 9, and that is a point on the graph of f. All right, let's go ahead and keep going here. All right, the rule of 4, GNAW. So 4 ways to represent a function. So it looks like it spells gnaw, but GNAW. So G is graphically by points in a coordinate plane where input values are on the horizontal axis and output values are on the vertical axis. So remember, horizontal axis is your y-axis, and output values are on your horizontal is the x-axis. Sorry about that. And your vertical axis is your y-axis. Numerically, by a table or set of ordered pairs that match input values with output values. Again, input is independent, that's your x. Output values is dependent, which is your y's. Where is my, let's erase that real quick. This is y. Okay. Algebraically, by an equation in 2 variables, you'll see the x and the y. And by verbally describing in words how the input variable is related to the output variable. Okay, so here we're going to evaluate functions. So given that f of x equals 2x squared minus 3x, evaluate the following. So here all we're doing is just recall what we did a moment ago. This is actually f of x equals y. So what we're going to do is we're going to take that value of 2 and we're going to plug it in for every time we see x, and we're going to simplify it. So for this one here, I'm going to say f of 2 equals, and then we're going to write the expression 2 parentheses. Here the x changes to a 2 squared minus 3 times 2. And over here, we're going to work it out, and we get that 2 times 2 squared is 8 minus 6, and last but not least, f of 2 is equal to 2. So our y output value is 2. All right, for the next one, f of x plus f of 2. So right here, we're going to change f of x to the expression. So we have 2x squared minus 3x plus, and we already know what f of 2 is, right? Because If you look at this f of 2, we just solved this previously. Now, if you wanted to rework it out, you could, but I already know that f of 2 is actually the value of 2. Okay? Now, I'm going to drop the parentheses because they're not necessary. So now we have 2x squared minus 3x plus 2. And really quickly, I didn't explain. If you look at f of x right here, this is f of x right there, so it equals this expression. That's why I rewrote 2x squared minus 3x, okay? So that's where that came from. It did just come there randomly. Now, from here, it says to evaluate it. Well, the only evaluation happened at this plus 2 we got, and I can't combine any like terms, and there's my final answer. All right, for letter C, it's asking me to type in 2x, okay? So with this function here, every time I see an x, I'm going to plug in 2x. So for this expression, we have 2 parentheses, we're going to change the x to 2x, close parentheses squared, minus 3 times 2x. Okay, so if you recall, like we did previously, the 2 stays here, but these have powers of 1 and 1. So we're going to distribute it. 1 times 2 is 2, so that's going to be 2 squared. 1 times 2 is 2, that's going to be x squared. And then negative 3 times 2x is negative 6x. From here, we know that 2 squared is 4. And that's x squared minus 6x. And last but not least, we're going to distribute this 2. 2 times 4x squared is 8x squared minus 6x. And from here, I don't actually have any things I can combine because these are unlike terms. So my answer is 8x squared minus 6x. All right, next we're going to do this letter D, which is negative f of x. So for here, it's telling me to write the function 2x squared minus 3x, but this negative in front is telling me to multiply this whole thing by negative, okay? So if you're unfamiliar with the negative, it really just flips the signs, but you can also make it a negative 1, so you can see that you distribute it to each term inside the parentheses. So this is going to give us, so negative f of x is going to equal negative 1 times 2x squared is negative 2x squared. Negative 1 times negative 3x is positive 3x. And we can't combine like terms, so that is our final answer there. All right, for letter E, now we're getting f of negative x. So again, just like the previous function, here we're going to substitute in negative x for x. So 2, instead of that x in there, we're going to put negative x, so that's taking the place, squared, minus 3 times negative x. All right, so negative x squared is negative x times negative x, which is going to give me positive x squared, and negative 3 times negative x is positive 3x. From here, you notice I can't combine the terms because they're unlike. One is x squared and one is x. So this right here is going to be my final answer. All right, on to letter F here. So for letter F, this one's asking me to do f of x plus 2. So we're going to change x to x plus 2. So we have 2 parentheses x plus 2 squared minus 3 times x plus 2. All right, so the way we're going to solve this is whenever I see something in parentheses and it's added or subtracted some numbers, so it's a binomial, when we square it, we just don't square x and square 2. That's not the way it works. What you're going to do is a squared means there's actually 2 of them, so you're going to write it twice. So x plus 2 times x plus 2. Over here, I'm going to go ahead and distribute. Negative 3 times x is negative 3x. Negative 3 times 6 times 2 is negative 6. All right, now from here, this is the part where you do have to recall. We're going to leave that 2 alone for now, and we're going to FOIL this out. So x times x is x squared. X times 2 is 2x. 2 times x is 2x. Okay, so we said 2 times x is 2x, and now we're going to do 2 times 2, and we're going to get 4. And notice I'm leaving this in parentheses, and the reason why is because I still have to distribute the 2. All right, from here, I'm going to still leave that 2 out there. I'm going to combine my like terms. So x squared plus 4x plus 4 minus 3x minus 6. And now I'm down to my last 2 steps. Now we're going to distribute the 2. So 2 times x squared is 2x squared. 2 times 4x is 8x. And 2 times 4 is 8 minus 3x minus 6. And then last but not least, we're going to combine our like terms, which will give me 2x squared. 8x minus 3x is 5x, and 8 minus 6 is 2. And there's our solution right there. All All right, now we're down to the last bit of slides here. So let's go ahead and take a look at these now. And this one is finding the domain and range of a function. Okay, so if you recall, the domain is going to be your x values and the range will be your y values. So for letter A, when it gives you like a list of points, like A, and this probably is going to be letter B. It's probably just got cut off, but let's change this to letter B right here. And C and D. So if you look at A, B, and D, those are called discrete functions. And why are they called discrete functions? Well, it's because they're individual points. Okay, that's individual, they're not connected, right? If you look at letter C, all the dots are connected, that's called a continuous function. But A, B, and D are individual points. Let me write this a little bit nicer. Let's see. Discrete. And we'll say individual points. Whereas continuous is one piece together. It's like a segment. All right, so when I'm doing domain and range, so let's go ahead and do this in a little bit darker blue. Okay, so for my domain are my x values, and since it's a list of numbers, we're going to keep it as a list, and we're going to put them in numerical order. Okay, so this is where order actually matters, because from domain, you read from left to right. So my first value, I'm going to underline all my values, 8, -2, 1, 8, and 2. So my smallest value is going to be -2, comma, my next one will be a 1, comma, then I see a 2, comma, and now you'll notice I have two 8s. I have this 8 right here and this 8 right here. When we're writing domain, we only write it one time. So for this one, we're just going to write 8 once. And then look at your numbers, make sure they're in numerical order. So from least to greatest, -2, 1, 2, and 8. So this is my list for my domain. All right, and the range is going to be done in the same manner, except the range are our y values. So -3, 4, 8, 6, and 7. So here, our smallest value will be -3 on the left. Then we go to 4, 6, 7, and 8. None of them repeated, so that's why I wrote every single one. And there's my range. All right, now for this next one here, for letter B, I'm actually we have the mapping here. So when we're doing the domain, it's pretty straightforward here. I like these kind of mapping problems because it already tells us what the x column is, right? So it doesn't really matter if there's more than one arrow coming out of those. We only write it once. For our domain, we have our x column is -5, 0, 2, 4. And it's already in numerical order. And notice, I'm not going to repeat any because I can only see the single numbers. And then for the range y, I look at the y column now, or the y mapping. And it's -3, -2, and +1. So even if there are multiple arrows, like the one has multiple arrows coming through it, I just write those numbers once, and that takes care of my range. All right, let's take a look at letter C. Now letter C, this is a continuous function. So your domain or range could be an interval, okay? So it's one piece. So like when I do these here, like for domain, so what I'd like to do, I like to look at the left side first. If you look at the left side, we have an arrowhead, and that arrowhead actually heads towards -infinity. And then I'm going to trace it all the way along, and you know it's one piece until I get to the other side, which is another arrowhead. And that arrowhead goes towards infinity. So I look at this line segment I just created, and now I see to the left it goes to -infinity, and to the right it goes towards +infinity. Okay? And then for the range, I do somewhat similar thing. I look at the very bottom. If you look at the very bottom, we actually have two arrowheads, both going towards -infinity. And at the very top, if you trace it, you stop at this highest point right there. And that appears to be the value of 2. And that's a closed dot. And here's a question. How do I know it's a closed dot? Well, if you look at the very top of that graph, there is no open circle, so you have to assume it's closed. So range is read from bottom to top. So from the bottom, we have a -infinity. And to the top, we have a value of 2. And just like previously when we did interval notation, infinities are always parentheses, and if you have a closed circle, that's a bracket. Open circles are parentheses. All right, now last but not least, we have a domain from a list of points on a graph. And here, so for my domain, I'm going to bring them up to the x-axis. So I have one right here. That's going to be -1, -2, -3. Now you'll notice here, there's two of them. 1, 2, but I only write it once. So that's -2. Then I have one right here, which is at 1. So notice there may have been multiple x's, but I'm only going to write those one time. Now for my range values, we're going to go from the bottom to the top. So my bottom, -3. Moving on up, we have -2, -1, 0, and 1. Let's see if I can fit that in there a little nicer. All right, so there you go, -3, -2, -1, 0, 1. All right, last but not least, we're gonna have our vertical line test. So the vertical line test is a visual way to determine if a curve is a graph of a function or not. So it's a set of points in a coordinate plane is the graph of y as a function of x if and only if no vertical line intersects the graph at more than one point. So what this pretty much says is when you draw a vertical line through your graph, it can only hit the graph once. And if it ever hits more than once, it is not a function. Okay, so let me go ahead and show you these examples here. So for the first one, now we do multiple tests. We don't just do one. So I'm gonna draw a vertical line. So there's one, notice it only hits once. Here's another one, only hits once. Here's another one, only hits once, and once. And you notice my lines are a little off, my bad. But never hit more than once, so yes, this is a function because it does pass the vertical line test. Over here, once. So every time it hit only once, so again, yes, it is a function. This next one, you can do the vertical line test just one time. Boom, boom. It hits once and twice. That is not a function. And the last one, pretty straightforward. Draw a line through here. Boom. Hits twice. Not a function. All right, now we're going to go through these last examples here. Use a vertical line test to identify graphs as a function or not. So for this first one here, it hits twice. No, not a function. For this one here, I hit multiple vertical line tests, and notice it only hits once every time, so yes, it is a function. This next one, 1, 2, 3, again, yes, it is a function. Over here, when I draw it, it hits twice. No, it is not a function. Okay. And that's gonna do it for the notes today.